All right, so today's lesson, again, guys, is on elimination method. And since we are really finding the same solution that you found when we did the substitution method, it's not a different answer. So the answer that we arrive at is still going to be a coordinate, just like it was for the substitution and like it was for the graphing method. So for your quiz will only cover substitution and graphing. It will not cover this method on the quiz. So I just want to make you aware of that. So if you go to page 8 first, when you're doing the elimination method, you do want to have your X and Y terms on the left. So it just tells you that in step 1, arrange both equations in standard form, placing the like terms one above the other. So sometimes when we're doing this elimination method, you might have to rearrange it so the X and Y terms are all on the left and it equals to the constant. All right, so example 1, I want you guys to write this down. This one will not come from page 9. This is coming from your textbook. And it says negative x plus 5y equals 13 and x minus y equals to 15. So in this particular example, one thing you notice about the x terms, they're actually opposite of one another. One is a negative x, one's a positive x. So what you're trying to do is eliminate one of the variables. So that is actually what you're looking for. This is not going to happen all the time. Sometimes you'll see step 1 is already done. Okay, step 1 is done because they're already lined up. But step 2, where you look to see which variable you would like to eliminate, there it is right there, because that's a negative 1 and that's a positive 1. So that step is already done. Because what I'm going to do now is combine the two equations together by addition. Okay, so when I do that, that's going to cancel these right out, which is what I want to happen. This is why it's called elimination method, because you want to eliminate one of the variables right away. And like I said, this is a perfect situation because one was already a negative 1, one was already a positive 1. In our next example, you'll see what you will have to do if one was not a negative 1 and a positive 1. Okay, but this one is already set up very nicely. So now you're going to combine your y's together. That's going to give you 4y. Combine 13 and 15, you're going to get 28. And then divide by 4, and you have y equals 7. Now, most students find this method easier than substitution. Okay, just because you don't have to go back and, substitute one back into the other and so forth. So now, obviously, again, we're looking for a coordinate. If we only have one answer, we got to go back and get the other answer. So in order to get the x coordinate, you can actually go back to either one of these equations and put y in as 7 and solve for x. It doesn't matter which one you go back and replace y. So I'm just going to do this one. And so I'm going to say x minus, and then my y is 7, equals 15. Solve for x. And I get x equals what? 22. And so now I have my x coordinate. And my solution is 22, 7. Okay. So on page 9, the very first question is letter A. And it says 5x minus 2y equals 4 and 3x plus y equals 9. So this one is not set up quite as nicely as the other one because, I don't have like a positive 2 and a negative 2. Okay, I have a negative 2 and a positive 1, and I have a positive 5 and a positive 3. So this is where you have to determine which variable you would like to eliminate, and then you can multiply that equation to make the variables just disappear. So let's just take a look. Which one would be the most reasonable one to do would be the y's. Now, can anybody tell me why? I know, why, and why's. All right. So why would you think that's true? Yes. Right, because then you would only have to multiply this bottom one down here by a positive 2. And when you do that, you do have to multiply every single term in the equation by 2. You just can't multiply this by 2, because when you do that, then you're really not changing the equation. Okay, I'm still keeping, if I were to solve this for y, I would still be able to graph the same line. So as long as you're multiplying every term, you're not changing the value of the problem. Okay, now you might ask, well, could I have eliminated the x's? What do you think the answer would be? Yes, you could, but then you would have to change this, the top one and the bottom one, because you could change both of these to 15, right? You could change this to a positive 15, so you would have to multiply this by 3. You could change the bottom one to a negative 15, so you would have to multiply this by negative 5. So, of course, we try to look for the easiest, the easier route. So, in this case, the easier one to do would be multiplying by 2. Okay? But, again, you got choices. Okay? It's just depending on how much multiplication you want to do. So, I'm not changing the first one, so I'm just going to rewrite that exactly like it is. So I'm not changing that. I'm going to multiply the second one by 2. So, that's going to give me 6x plus 2y equals to 18. So don't forget, even the number after the equal sign has to be multiplied by 2. So now I've set it up where these will be eliminated right away. And then I add my x's together. That'll give me 11. And this will give me 22 for my constants. Divide by 11. And what is my value of x? 2. Now, I suggest when you are going back to find the y-coordinate, I would suggest going back to the original problems and not where you actually made the numbers larger. Okay, I always like to deal with the smaller of the numbers. Okay, so this time I'm just going to go back to, doesn't matter, I'll go back to this one here, 3x plus y equals 9. So I found x to be what? 2. So I'm going to say 3 times 2 plus y equals 9. So this is going to be 6 plus y equals 9. So what is y? So y equals to 3. And then I'll just write my coordinate as 2, 3. Don't forget to write your solution. So again, we're finding the same answer if we were to do the substitution method. We're finding the same answer if we were to graph these, and they would intersect at 2, 3. Okay? Do you think this is easier than substitution or what? You think so? Okay. I got one vote. All right. So let's do letter B. Okay, we're still on page 9, so we have 3x minus 5y equals 13, and x minus 2y equals 5. So take a careful look at your variables and which one would be probably the one you would do that would cause you less work, where you wouldn't have to multiply both. The x's, okay? If you did the y's, you could make one a positive 10, one a negative 10, but that means you would have to change both. So if you really only want to multiply, just one of them, I would just multiply the bottom one by, what would we multiply it by? Negative 3, because wouldn't we want the bottom to be a negative 3x and the top be a positive 3x? Yes, that's what we want, opposite signs. So I'm going to go ahead and rewrite the first equation exactly like it is. I'm going to multiply the bottom one by negative 3, so that's going to give me negative 3x plus 6y equals negative 15. So now when I combine these together or add them together, the x's cancel out. How many y's do I have? Just one. Is that correct? And then this will give us what? Negative 2. So there I am with y equals negative 2. Then I'm going to go back to one of the originals and replace y with negative 2. So I'll just start with this one and say 3x minus 5 times negative 2 equals 13. Now, when I do this, I'm going to have 3x plus 10, because that's a negative 5 and a negative 2. Subtract 10, that's going to give me 3x equals the 3. So x equals 1 when I divide by 3. So my coordinate then is 1, negative 2.